Effect of temperature on reaction rate. I mean, when a reaction is carried out, if you apply temperature, then how it will affect the rate of reaction. Generally, when you apply temperature, the rate of reaction always increases. And why it increases? Because when a reactant convert to product, it must cross an energy barrier. I mean, you consider that a hill, this side of the hill contain reactant, that side of the hill contain product. If a reactant convert to product, it should cross the hill. I mean, they have to cross an energy barrier, then only they can convert to product, otherwise they cannot convert to product. And how much energy is required to convert reactant to product? That is called threshold energy. I mean, if a reactant do not get the threshold energy, they cannot be converted to product. Always remember that. So when you apply temperature, then when the temperature decreases the amount of threshold energy, and that is why the rate of reaction going on increasing. I mean, the reactant easily can convert to product side. Now, there is a calculation. If you increase temperature by 10 degrees Celsius, suppose a reaction is carried out at 25 degrees Celsius and you increase the temperature up to 35 degrees Celsius. How much increase? 10 degrees Celsius. For every 10 degrees Celsius rise in temperature, the rate of the reaction may be double or triple. I mean, it increases by twice or thrice. So that is why when you increase the temperature, rate of reaction always increases. So I'll give you, you can write like this: the rate of reaction always increases with increase in temperature. With increase in temperature. It was found that for every 10 degrees Celsius rise in temperature, the rate of reaction increases by twice or thrice. I mean, it may be double or triple. It is represented by temperature coefficient. So temperature coefficient is equal, you can find out temperature coefficient, rate constant means rate of reaction. As the rate increases, rate constant also increases. Rate constant at T degree Celsius divided by rate constant at T plus 10 degree Celsius. You can find out the temperature coefficient like this way. Temperature coefficient is equal rate constant at T degree Celsius divided by rate constant at T plus 10 degree Celsius. So when you increase the temperature of a reaction, then the rate of reaction always increases. And how much increases? You can represent it by temperature coefficient. For every 10 degrees Celsius rise in temperature, the rate of reaction increases by twice or thrice, and this is represented by the temperature coefficient. And if you want to find out the temperature coefficient, rate constant at T degree Celsius, I mean at T degree Celsius, what is the value of K, divided by rate constant at T plus 10 degrees Celsius. I mean after increasing 10 degrees Celsius, what is the value of rate constant, you divide it, then you will get the value of temperature coefficient. Normally after increasing 10 degrees Celsius, you will get the temperature coefficient value 2 or 3. I mean it may be double or it may be triple. So like this way, the temperature can affect the rate of a chemical reaction. Thank you. Activation energy. This is very important for exam. What is activation energy? The minimum amount of energy, the minimum amount of energy absorbed by the reactant molecules, to convert to products is called threshold energy. How much energy required to convert a reactant to product, that energy is called threshold energy. And this threshold energy is represented by the symbol E naught. E naught is the symbol. The extra amount of energy absorbed by the reactant molecules, so that their energy become equal to threshold energy E naught, is called the activation energy. So activation energy means threshold energy minus the average kinetic energy of the reactant molecules. Now I will tell you what is activation energy. Suppose if you want to plot suppose this side energy and this side progress of reaction. Suppose this is the energy of reactant ER and this is the energy of product EP. To convert the reactant to product, it must cross an energy barrier like this, then it can convert to product, and this energy is said to be the threshold energy. I mean, without threshold energy, reactant cannot be converted to product. But as you know, when a reaction takes place, the reactant molecule undergo collision, and during their collision they provide some amount of energy. If that amount of energy is this much, if the reactant energy is this much, then directly it can convert to product. But suppose the collision energy is not sufficient to convert the product, I mean collision energy is not equal to the threshold energy, then what you have to do? You have to supply some amount of energy from outside, and that supplying amount is called activation energy. Suppose after collision the reactant get this much amount of energy. After collision they get this much energy, so it cannot convert to product. So that is why you have to supply this much extra energy, and which is called the activation energy. So this is the energy of reactant. During their collision they get this much, so after that you supplied extra this much, then it convert to product, and this extra amount of energy which you have supplied, that is called the activation energy for the reaction. So activation energy is the energy that you have to supply to get the threshold amount, and that is called the activation energy. Thank you.